So today we are going to discuss about geometry for class 6th Olympiad. So let's discuss about a point. So first of all we'll discuss about what is point. So in general, let's take an example over here. So this one is let's say we have this point. So we'll say this is a point A. So the definition of a point is a mark. So this is a mark. So mark of position. Mark of position represented in form of dot. Represented in form of dot. So like this is point B, here I have C, this is D, so this is E. So the dot point that we represent, this is known as a point. The smallest dot near to the line, that is a dot. So for example, if I just put this one, so this is a dot, this is a dot, this is a dot. So these are A dash, B dash, C dash, D dash. All these are the point. So we will say that we will have n number of points in a plane. So whatever this that I have represented, this is x dash, y dash, z dash, or w dash. So this, in this plane we have n number of points that are actually geometrical representation of point. So now the point to be noted over here, so the noting point is a point has no length, no width, and no thickness. So what we said, a point has no length, no width, there is no width or breadth, and finally is no thickness. Okay, so these are the points that you should have to know. And one more thing, whenever we represent a point, so for example, let's take an example. This is the here I am just representing, always we represent a capital letter A. If this is a point, this is represented by capital letter B. Okay, so after completion of the point, let's move to the another thing, that is line segment. What is line segment? That is line segment. So what is line segment? So line segment is, if we have 2 points, let's first understand this is let's consider we have 2 points. So like this is the point A, and this is the last point of here I am denoted, this is point B. So the line segment between 2 points A and B is known as a line segment. So this is known as this AB, this A and B, we are representing this is as a line segment. So a straight path, or a straight we can say a straight path between 2 points, let's A is a 1 point, this is 1 point, and this is the another point, A and B is the line segment, and how we will represent the line segment? AB, and after that we will put the bar over here. So the A and B will have some fixed distance. Okay, so it will have definite length. So what are the points about the line segment? So the first point about the line segment is it's a defined length or definite length. Okay, so one more thing, like got it na? we have a definite length of a line segment. So let's move to the uh, another topic, that is ray. What is ray? So ray, a line segment which can be extended in one direction till infinity. So like let's take an example. We have a this is the, here we have a bulb. Okay, this is a bulb and it emits a light. So that light, it's emitting it to the this one side is fixed and the another side is till infinity. So this is one ray. So ray is a point, like from a bulb, we are sent when we switched on the bulb, from a one point the rays are emitted from one direction and it will go to the infinity to another direction. So this point, let's consider this is a point A, and till infinity it's a, so the point is, ray has no definite ray has no end point. A ray has one endpoint, that we'll say A. So ray has one endpoint and no definite length, and finally no definite length. So the point that we want to say, one endpoint and no definite length, okay, that's known as the ray. So come to the another definition of line. Now we will reach at the line, what exactly the line is. So a line segment AB that can be extended infinitely in both the directions. So let's say we have a point A and another point we will say B, and now let's we will combine these 2 points. When it will be set as a line, so it can be extended infinity towards this direction, and it can be extended infinity towards this direction. So that's known as a line. So now we'll come to the definition of a line. A line segment, this is the line segment, AB is the line segment. So the line segment AB, when extended infinitely in both direction, is called line, and that line is AB here in the blue example. So let's discuss about the points of a line. The first point that we are going to discuss, the point number 1, a line has no end point. First thing is, a line has no end point. Second, a line has no definite length. A line has no definite length. Point number 3, a line can't be drawn. It can simply be presented in one plane. Okay, so that's we'll not consider this point. I think we can draw the line, and it can be represented on the plane as well. Okay, so now we'll come to the another topic or another content that we can say. Let's move to the another part. Another part is collinear point. What is collinear point? Collinear. What is collinear point? So let's consider we have 3 points. Collinear point is if 3 or more points on the same plane, on the same line, that is known as the collinear point. So for example, if I have this one, and if I join all of them like this, So this point A, this point B, this point C, and this point D, all these points are lying in the same plane and on the same line, so that is known as the collinear points. Where if I take here x and y, x and y are known collinear points. Okay, we can draw the line segment, but these are not on the this AB. If I say this is a line L, and in this line L, A, B, C, this all these points are lying on this line L, so these are known as the collinear point. But x and y, this x and y are not the collinear points. Understood? Okay, so another topic is non-collinear, that we already discussed. Non-collinear, non-collinear point. So what exactly the non-collinear point? So like one point is here, one point is here, one point is here, one point is here, one point is here. If I draw one line, we can join the two lines. Another line we can join, another we can do, another we can join, another we can join. So let's take, this is A, B, C, D, E. So these lines we can draw. This is line L1, this is line L2, this is line L3, this is line L4, this is line L5. So they have their own lines. So this is known as the collinear points. Sorry, this is known as the non-collinear points. So let's recap what we discuss. So first we discuss about what is a point. Then we discuss about the point has no length, no width, and no breadth, and no thickness. Line segment have a fixed definite length. It will be like A and B will be definite length. Ray from one point is fixed, and another point it have no definite length. Line is A and B, but we can extend it to the infinity. Okay, so then we, after that, we discuss about collinear point and collinear and non-collinear points. Okay, so now we are going to discuss about how many lines we can draw from a point. So like number of lines that we can draw through non-collinear point. So now the point that we are going to discuss is very specific. So how many we have to find how many number of lines that can be drawn through and non-collinear. This is non-collinear points. So let's take an example. We have this value n is equal to 5. So we have 5 non-collinear points. So we have to find how many lines we can draw from these 5 non-collinear points. So let's take 5 non-collinear point, 1, 2, 3, 4, and this one is 5. So one way will come. Okay, we can line this A and B. Another we can C and D. This BC. Another will say it's E. Then we will say F. Okay, so this is 1, 2, 3, 4. 4 lines we can draw, but we cannot find like this. How we can find? Let's have a formula. So the formula for this one is n minus 1 divided by 2. So let's take n value is 5 here. Now 5 minus 1 divided by 4 divided by 2. So we have 5 multiplied by 4 divided by 2. So this is 2. So how many number of lines we can draw with this 5.10 lines? So how we can do 1, 2, 3, 4. 1, 2, 3, 4 lines we have here. Another is 5, 6, 7, then 8, then 9. Okay, so let's take now we'll count this one. How many number of lines we have here? This is 1, 2, 3, 4, 5, 6, 7, 8. Okay, Then we have here 9, this is ninth line. Anyone we missed? Total number of lines that we can draw is 10. Let me check any line that we missed. Okay, that line we missed 10. So total number of lines that we can draw from this one. So if anybody will give you like n is equal to 15, so it's not possible to identify with the help of this point to join like this one. It's very difficult to identify how many number of collinear point you can do. So the better way, you can use this formula, n is equal to n minus 1 divided by 2, how many number of lines in the collinear plane. So this formula will help you. So you can solve one question. I will give you one question. Tell me number of lines drawn. Number of line can be drawn. You will write the question. Number of line can be drawn from a point. If we have 75 points, then how many number of lines we can draw in a collinear points? These collinear points, we have the number n is equal to, here what we said, n is equal to, okay, the value of n is equal to here 75. So you have to tell how many number of lines we can draw. Find number of line we can draw in non-collinear points. All these 75 points are in a non-collinear, so you have to find how many number of lines we can draw. So the formula for this one is n minus 1 divided by 2. So what we did, we'll substitute the value here, 75 minus 1 divided by 2. So let's solve this one. 75 multiplied by 74 divided by 2, 2 3 ja and 2 7 ja. So the simple way is you have to multiply this one. So this number of lines, whatever the result it will come, so this number of lines we can draw from this 75. 75, if we have 75 non-linear points, then we can draw. Any doubt? So what is the, when we multiply this one, so here we will have 5, then we will have here 7 2. So this number of lines you can draw from this 75 points. Okay, let's start with discussion with about plane. What exactly our next topic is, we'll discuss about plane. So let's discuss about plane. What is planes? Okay, so the definition, when we talk about the definition is a flat surface which can extend endless in all the direction is known as plane. So if we will take an example like this is one plane, if I'll take another example like this is another plane here. If I take another example, so like this is another plane. So all these are, this is plane 1, this is plane 2, this is plane 3. I'm just representing this one. So basically all these are smooth surface that can be extend infinity to their own directions. So all these are planes. In both the direction it can be extended. Okay, so let's have a point about it. A plane has an infinite length and breadth but have no thickness. What it means? A plane has infinite length and breadth but has no thickness. So the point is, no has length and breadth but has no thickness. Got it? What we said, has no thickness. Okay, so now if we have three known collinear points, okay, so it will lie in a one plane. So let's say I will take an example of a plane. So these are the 3 points, so this is one plane. If I have 3 points like this, so this is another plane. If I have 3 points like this, so this is another plane. If I have 4 points like this is another plane. So this is an example of a plane. So this is A and B, this is C and D and E. Here it's C, let's consider here. So the point that I want to just tell you how we are representing this one. So these are the 3 points, 1 2 3 3 points that we are any three points you can take and you can combine them. It will become a plane. Okay, so now let's have a discussion about plane figures. When an enclosed figure drawn in a plane with a flat surface is known as a plane figure. So like we can have an example here. This is a triangle. We have circle also. We have rectangle also. Okay, so all these are the plane figures. Plane figures means, so we can have segments. So now we will discuss about number of line segment. Number of line segment. What we are going to discuss about number of line segment. Number of line segment means if I have a point like A point, we have B point, we have C point, D point, E point, and till we have the infinity point are on the line segment. Are on line segment. Line segment that we can say AB is that let's consider PQ will be a line segment. Okay, then the number of line segment determined by point N. So what we have to do, we have to find that in this PQ how many number of line segments are in this one. So here N is equal to N minus 1 divided by 2, that we discussed earlier now. So how many number of line segments we can draw. So same way now what we discuss, okay, now we will discuss about conjugate line segment. Okay, so what is conjugate line segment? If two lines, if the length of the two line segments are same, then they are called a conjugate line segments. Conjugate line segments, we will say if this is a point A, another is this is point B. If we combine this line, same way we have C and D. In geometry, what we represent like C and D, this we will see AB, this AB will be the length of this line. Okay, another CD will be the length of this line. Okay, so if I represent this AB and this is equal to CD, and after this one I will put like this. Okay, so this is the symbol, that the symbol that I am just going to represent here, that is the conjugate symbol. What is the symbol? Conjugate, sorry, concurrent, not conjugate, concurrent line segment. That is concurrent line segment, not conjugate, concurrent line segment. So these two lines are concurrent. What I say, AB is concurrent to CD. Okay, so now we will come into the how we units and the symbols. So what will be the unit of a line? So I am just writing here unit and its symbol. Okay, and the relationship. Okay, first we'll understand the unit. So we will write millimeter. So millimeter we will represent by mm. Then we will have centimeter. So centimeter, it is represented by cm. Decimeter. Decimeter is represented by dm. Then we will have decameter. Decameter we will represent it by dm. Then we will have hectameter. Hectameter we will represent it by hm. Then we will have kilometer. Kilometer we will represent it by kilometers, like this. So now we will represent the relationship of millimeter. So 1 millimeter is equal to 1 upon 1000. This is millimeters. This is mts. Okay. So 1 centimeter is equal to 1 upon 100. 1 decameter is equal to 1 upon 10 mts. 1 decimeter is equal to 1 upon is equal to 10 mts. 1 hectameter is equal to 100 mts. 1 kilometer is equal to 1000 mts. Okay, so the point that is here, you should have this table in your mind. And one more thing, how we will represent this thing. So like if I have this point, if a person travel from point this A to B, and when he reached at point C, the distance of this one is like 100 meter. Then he will reach to the point E. This point, the distance is 1 kilometer. If another point that he will route, he has travels 5 kilometer. So the total distance of this one is 1 kilometer plus 5 kilometer plus 100 meter. So the total distance is 6 kilometer and 100 meter. So if you want to represent as in 6 point, okay, 6.1 kilometer. Okay, understood? So now we will come into the let's have a discussion. We have a point. Let's take a point. This is a point A, this is point B, and this is point C. Okay, so this point A is equal to this point B. So what we say, AB is equal to BC. So what we have to do, if anybody will say the value of this AB point is equal to 5 centimeter, and find value of AC. So how we will find, how this AC point will be created? AC point is equal to AB plus BC. This is equal to from this to this and this to this. So what is this value? AB is equal to AC. So we can write this is equal to AB plus AB, because both the points have the same points. So we will say it's a 2 of AB, and we know the value of AB. AB is equal to 5 centimeter. So this AC is equal to 10 centimeter. So the total value of this length of this AC is equal to 10 centimeter. Clear? Okay, let's repeat it again. We will have 2 points. This is point A, and this is point B, and this point C. Okay, the distance between this point, the distance between this point A and B, this point, the distance between this point is, we have given here 5 centimeter. Okay, now another condition that we have given is this one. This point AB is equal to this one BC, from here to here. Both the points are equal. So this AC, how this AC is created? AC is equal to AB plus BC. Clear? This AB plus BC, then we will get the AC. So this BC is equal to AB. We can put the value of AB over here. Both are equal. When we add this one, so this will become to the 2AB. Clear? Now what is the length of this AB? AB length is 5 centimeter. Here we have 5 centimeter. So we put the value of this AB here, 5 centimeter. When we multiply, so the final result is 10 centimeter. So the length of this AC is 10 centimeter. Clear? Okay. So now we'll move to the another point. Let's have discuss another point. Parallel line and intersection lines. Okay, so let's have a parallel line. What is a parallel line and what is intersection line? I have a line that is, this is one line, and I have another line, this one. Okay, so let's take this as a parallel line. So we'll take another line. So when we set a line, this we have a line A, B, another line we have C and D. When we said this AB is parallel to this CD, what are the conditions? So the condition is a line is said to be parallel. For example, this point, at any point, this distance, that this is the distance, this distance D, D, D. If the distance is equal at any point of time on between these two lines, so these lines are said to be the parallel lines. Clear? What is the definition of a parallel line? The two lines are said to be parallel when the distance between the 2 points, the distance between these two lines, sorry, at any point, okay, is always equal. Then it will be the parallel line. So what we discuss here, parallel line. Parallel line. Then what is intersection line? Intersection line. Intersection line means I have a line AB and this is BC and it is intersecting at some common point, like P will be the point where it is intersecting. So this is known as the intersection line. Okay, clear? Now we will discuss about some properties of a plane. So we have inclinance property of plane. The first property is, so if anybody will say some planes are coplanar points. So coplanar point means this is a plane and these lies in this one. So this is A, B, C, D, E and F. All these are in the same coplanar plane. Okay, so same way a line segment belonging to the same plane is called as a coplanar line. So let's take, we have this one, this is a line segment. Okay, this is line segment L1, this is another line segment L2, this is line segment L3. All these lines are belonging to the same coplanar, same coplane. Okay, line L1, L2, L3 are the same coplanar. Okay, the point 3 will be, only one line can be drawn through a point and the line is in a coplanar between A and B and it can be extended to infinity. Okay, in a curve. So now we'll discuss about a few of the questions. So let's take the questions first.